The year is 2025, and we think we know the story of human civilization. Agriculture began around 12,000 years ago. The first cities rose from the fertile river valleys of Mesopotamia. Writing emerged, empires flourished, and here we are today with smartphones and space stations, convinced we represent the pinnacle of human achievement. But what if everything we believe about our past is wrong? What if 300,000 years ago, long before the first pyramid was built, long before the first wheel turned, there existed a civilization so advanced that it would make our modern world look primitive by comparison? Not aliens, not visitors from distant stars, but humans, our ancestors, people who walked this same earth, breathed this same air, and built something extraordinary that time has completely erased. This isn't science fiction. This isn't fantasy. This is a question that archaeologists, anthropologists, and historians are beginning to ask with increasing seriousness. Because when you really examine the evidence, when you look at the gaps in our knowledge and the mysteries that conventional archaeology can't explain, a disturbing possibility emerges. Maybe we're not the first advanced human civilization. Maybe we're just the most recent one. Stay with me, because by the end of this video, everything you thought you knew about human history might change forever. And if you're new here, welcome to a channel where we explore the questions that make you think differently about everything. Hit that subscribe button, because today we're diving deep into one of the most controversial ideas in archaeology. The story begins with a simple observation that should make everyone uncomfortable. Modern humans, anatomically identical to us, have existed for roughly 300,000 years. That's not a guess. That's what the fossil record tells us. The oldest known remains of Homo sapiens were found in Morocco and dated to around 300,000 years ago. These weren't primitive ape-like creatures. These were people with brains just like ours, capable of the same complex thoughts, the same problem-solving abilities, the same creativity that built the pyramids and put humans on the moon. But here's where it gets strange. According to mainstream archaeology, these anatomically modern humans spent the next 290,000 years doing essentially nothing. They hunted, they gathered, they made basic stone tools, and they lived in small nomadic groups. For nearly 300 millennia, beings with the same intellectual capacity as Einstein, Da Vinci, and Tesla supposedly never developed agriculture, never built permanent settlements, never created complex technology. Then suddenly, around 10,000 years ago, everything changed. Almost overnight in historical terms, humans began farming, building cities, developing writing systems, and creating the foundations of civilization as we know it. This dramatic shift is so abrupt that archaeologists have a special name for it. They call it the Neolithic Revolution. But revolution implies rapid change, and rapid change in human development should make us ask an uncomfortable question. If humans were capable of this revolutionary leap 10,000 years ago, why couldn't they have made similar leaps earlier? What if they did, and we simply haven't found the evidence yet? Or worse, what if we've found the evidence but dismissed it because it doesn't fit our preconceived timeline? The problem with ancient history is that it's written by the winners, and time is the ultimate winner. It erases everything. Think about how little would remain of our own civilization if it vanished tomorrow. Our cities are built with materials that decay. Steel rusts, concrete crumbles, plastic breaks down, and glass shatters. Even our most impressive monuments wouldn't survive more than a few thousand years without constant maintenance. Now imagine trying to find evidence of a civilization that existed not thousands, but hundreds of thousands of years ago. The ice ages alone would have scraped away most surface evidence. Rising and falling sea levels would have drowned or scattered the ruins. Tectonic activity would have buried or destroyed archaeological sites. Erosion, volcanic eruptions, and the simple passage of time would have eliminated almost every trace of human achievement. This is why the absence of evidence isn't evidence of absence. Just because we haven't found the ruins of an ancient advanced civilization doesn't mean one never existed. It might mean we're looking in the wrong places, using the wrong methods, or making the wrong assumptions about what to look for. But the mystery deepens when you start examining the artifacts we have found. Scattered across the globe are objects and structures that don't fit comfortably into our timeline of human development. The precision of ancient stonework at sites like Pumapunku in Bolivia, where massive blocks are fitted together with tolerances that would challenge modern engineering. The unexplained sophistication of the Antikythera mechanism, a Greek device so complex that nothing comparable appeared in Europe for another 1,000 years. These anomalies are usually explained away as isolated examples of ancient ingenuity, lost techniques that died with their creators. But what if they're not isolated at all? What if they're remnants of a much larger pattern that we're only beginning to glimpse? Consider the Younger Dryas period, approximately 12,800 years ago. This was a time when global temperatures suddenly plummeted, triggering a mini ice age that lasted over 1,000 years. The cause of this climate catastrophe remains hotly debated, but its effects were devastating. Massive extinctions swept across North America. Entire ecosystems collapsed. And if any advanced human settlements existed at that time, they would have been wiped out completely. This period coincides almost perfectly with the end of what archaeologists call the Upper Paleolithic and the beginning of the Neolithic Revolution. It's as if the slate was wiped clean and humanity had to start over from scratch. The survivors would have been small groups of hunter-gatherers, people living at subsistence levels with no time or resources to maintain complex knowledge or technology. But here's what's fascinating. Legends from around the world speak of a great flood, a time of catastrophe when the old world ended and the new world began. These stories appear in cultures that had no contact with each other, from the biblical account of Noah to the Mesopotamian epic of Gilgamesh, from Hindu Puranas to Native American oral traditions. They describe advanced civilizations that were destroyed by global catastrophe, leaving only a few survivors to rebuild. Mainstream archaeology dismisses these as myths, symbolic stories created to explain natural phenomena. But what if they're not myths at all? What if they're cultural memories, distorted by thousands of years of oral transmission, but rooted in actual historical events? This brings us to one of the most intriguing pieces of evidence for a lost advanced civilization: the precision and sophistication of astronomical knowledge possessed by ancient cultures. The builders of Stonehenge understood celestial mechanics well enough to create a monument that tracks solar and lunar cycles with remarkable accuracy. The Maya developed a calendar more precise than the one we use today. Ancient Egyptians oriented their pyramids to cardinal directions, with an accuracy that rivals modern surveying techniques. This astronomical knowledge required generations of careful observation and mathematical calculation. It suggests long periods of stable civilization with the leisure time and resources necessary for scientific advancement. Yet according to our timeline, these achievements emerged from cultures that had only recently abandoned nomadic hunting and gathering. The mathematics alone should give us pause. The ancient Babylonians used a sophisticated base 60 number system. The Maya independently discovered the concept of zero. The ancient Greeks calculated the circumference of the Earth with remarkable precision. These weren't lucky guesses or primitive approximations. They represent advanced mathematical understanding that supposedly developed in just a few thousand years. But perhaps the most compelling evidence comes from the field of genetics. Recent studies of human DNA have revealed something unexpected. Around 70,000 years ago, the human population crashed to perhaps as few as 10,000 individuals. This genetic bottleneck, known as the Toba catastrophe theory, suggests that humanity came dangerously close to extinction. What caused this near-extinction event? The leading theory points to the eruption of Mount Toba in Indonesia, one of the largest volcanic explosions in Earth's history. The eruption would have triggered a volcanic winter, blocking sunlight and causing global cooling that lasted for years. Any large human settlements would have been devastated. But here's the crucial point. The genetic evidence shows that humans not only survived this catastrophe, but subsequently spread across the globe with remarkable speed. Within a relatively short time, they had colonized Australia, reached the Americas, and adapted to environments as diverse as Arctic tundra and tropical rainforests. This rapid expansion and adaptation suggests organizational capabilities and technological knowledge far beyond what we typically associate with Stone Age hunter-gatherers. The timing is significant. If an advanced human civilization had existed before the Toba eruption, it would have been almost completely destroyed. The survivors would have been small groups living in isolated refuges, forced to abandon complex settlements and technologies in favor of basic survival. Over generations, the knowledge of the lost civilization would have faded, preserved only in fragmented form through oral traditions and genetic memory. This pattern of catastrophic destruction followed by slow recovery might have repeated multiple times throughout human history. Each ice age, each massive volcanic eruption, each asteroid impact or climate shift could have reset human civilization, forcing survivors to rebuild from almost nothing. We might be living through just the latest iteration of human advancement, unaware that previous cycles reached heights we can barely imagine. The evidence for this possibility exists all around us, hidden in plain sight. Ancient monuments that required engineering skills we're only beginning to understand. Artifacts that suggest technological capabilities beyond what their supposed time periods should have allowed. Genetic and archaeological mysteries that don't fit our linear model of human development. But the most intriguing evidence might be the one we're least likely to recognize. What if the ancient advanced civilization didn't build with stone and metal? What if they developed along completely different technological lines, creating achievements that left no archaeological signature we would recognize today? Consider this possibility. What if 300,000 years ago, human civilization took a path so radically different from our own that we wouldn't even recognize their achievements as technology? We assume that advance means what we've built. Cities of steel and glass, computers and satellites, nuclear power and space exploration. But that's just one possible direction for intelligent development. What if they mastered biology instead of physics? What if they learned to shape living organisms the way we shape metal and silicon? Imagine a civilization that grew their buildings instead of constructing them, that bred animals for specific purposes we can't even conceive, that understood genetics and cellular manipulation at levels we're only beginning to explore. Such a civilization would leave virtually no trace. Living structures decay completely. Biological machines return to the earth. Even the most sophisticated organic technology would be indistinguishable from natural processes after thousands of years, let alone hundreds of thousands. This isn't pure speculation. We're already seeing the early stages of biological technology in our own time. Scientists are engineering bacteria to produce fuel, growing organs in laboratories, and creating materials from spider silk proteins manufactured by genetically modified organisms. We're learning to program living systems like biological computers. If we can make these advances in just a few decades, what might a civilization accomplish given hundreds of thousands of years to perfect such techniques? The clues might be hiding in our own DNA. Recent discoveries have shown that the human genome contains vast stretches of so-called junk DNA, sequences that don't appear to code for proteins or serve any obvious function. For decades, scientists assumed these regions were evolutionary leftovers, meaningless remnants from our ancestral past. But new research suggests something far more intriguing. Some of these sequences appear to have regulatory functions we don't yet understand. Others contain patterns that seem almost too organized to be random. A few researchers have even suggested that portions of human DNA might contain information encoded by intelligence, though such ideas remain highly controversial. What if these mysterious sequences aren't evolutionary accidents? What if they're the remains of genetic engineering performed by an ancient human civilization that understood biology far better than we do? A civilization that could modify their own species, enhance their capabilities, and leave information encoded in the very structure of life itself. This would explain one of the most puzzling aspects of human evolution. Compared to other primates, our development seems almost impossibly rapid. Our brains tripled in size in just a few million years, an evolutionary blink of an eye. We developed language, abstract thinking, and complex social structures with a speed that challenges conventional evolutionary theory. Some scientists have proposed that this rapid development was triggered by environmental pressures, dietary changes, or genetic mutations. But what if it was guided? What if an earlier human civilization, understanding the mechanisms of evolution and genetics, deliberately accelerated their own species development? The evidence might be written in our very nature. Humans are the only species on Earth that seems fundamentally dissatisfied with the natural world. Every other animal adapts to its environment, but humans constantly seek to change and control their surroundings. We alone among Earth's creatures seem driven to explore, to question, to push beyond the boundaries of what exists. This restless drive might be more than just random evolution. It might be a programmed imperative, a biological command left by predecessors who understood that survival required constant advancement, constant preparation for the next catastrophe that would inevitably come. The psychological evidence supports this possibility. Humans possess what psychologists call displaced reference, the ability to think about things that aren't immediately present. We can plan for futures we've never experienced, prepare for dangers we've never encountered, and dream of possibilities that don't yet exist. This cognitive ability is remarkably sophisticated and seems far more developed than necessary for basic survival. But it would be essential for a species trying to preserve knowledge across catastrophic interruptions. A civilization that knew it might be destroyed would need survivors capable of thinking beyond immediate needs, of maintaining complex information across generations, of rebuilding from fragments and memories. The cultural evidence is equally compelling. Every human society, no matter how isolated, develops creation myths that describe a golden age, followed by catastrophe and slow recovery. These stories are remarkably consistent across cultures that had no contact with each other. They speak of a time when humans possessed great knowledge and power, when they lived longer, accomplished greater feats, and understood secrets that have since been lost. Anthropologists typically explain these myths as psychological projections, ways of coping with the hardships of life by imagining a better past. but the consistency is troubling. Why would completely separate cultures independently develop such similar stories unless they were based on some shared experience or inherited memory? The linguistic evidence adds another layer to the mystery. Comparative linguistics has revealed that many fundamental words appear in languages across the globe, even in groups that supposedly had no historical contact. Words for basic concepts like water, fire, and family show surprising similarities in languages separated by thousands of miles and thousands of years. Some linguists propose that these similarities reflect a common ancestral language spoken by early humans before they spread across the globe. But the depth and sophistication of these shared roots suggests something more complex than the simple vocabulary of hunter-gatherer bands. They hint at a rich, developed language capable of expressing abstract concepts and complex ideas. What if these linguistic fragments are the remains of a much more advanced language system? What if they preserve echoes of scientific, philosophical, and technical knowledge that once existed at levels we can barely comprehend? The astronomical evidence provides perhaps the most concrete support for this possibility. Ancient monuments around the world demonstrate knowledge of celestial mechanics that supposedly wasn't discovered until modern times. The builders of these structures understood precession, the slow wobble of Earth's axis that takes 26,000 years to complete one cycle. This knowledge couldn't have been acquired through casual observation. It requires systematic study across many generations, the kind of long-term scientific project that only a stable, advanced civilization could maintain. Yet according to our timeline, these monuments were built by cultures that had only recently developed agriculture. The precision is astounding. The Great Pyramid of Giza is aligned to true north with an accuracy of just 3/60ths of a degree. Its base is level to within just 2.1 centimeters. Its dimensions encode mathematical relationships, including pi and the golden ratio. These aren't approximations or lucky accidents. They represent engineering and mathematical knowledge that rivals our modern capabilities. But perhaps the most unsettling evidence comes from the geological record itself. Recent studies have identified what researchers call the Anthropocene, a new geological epoch defined by human impact on the planet. Our industrial civilization has altered atmospheric chemistry, ocean composition, and global climate in ways that will remain detectable for millions of years. If a previous advanced human civilization existed, it too would have left geological signatures, changes in atmospheric composition, alterations to natural mineral distributions, modifications to the planetary environment that would show up in rock layers and ice cores. The question is whether we would recognize such signatures or dismiss them as natural phenomena. Some researchers have begun looking for exactly these kinds of markers in deep geological strata. They're searching for anomalous concentrations of metals, unusual isotopic ratios, and sudden changes in atmospheric composition that might indicate industrial activity in the distant past. The work is still in its early stages, but initial results are intriguing. Certain ice core samples from Antarctica show unexplained spikes in atmospheric methane and carbon dioxide dating to periods long before any known human activity. Some deep ocean sediments contain trace elements in concentrations that don't match known natural processes. A few geological formations show signs of high-temperature events that don't correspond to volcanic activity or meteor impacts. None of this proves the existence of an ancient advanced civilization, but it raises questions that deserve serious investigation. If such a civilization existed and was destroyed by natural catastrophe, the geological signatures might be the only evidence that survives. And if we're not looking for them, we'll never find them. The implications of this possibility extend far beyond archaeology or anthropology. If human civilization has risen and fallen before, if we're not the first to reach advanced technological capabilities, then our assumptions about progress, about the future, about our place in the cosmic story, all need to be reconsidered. It means that advancement isn't inevitable or permanent. Civilizations can be lost, knowledge can be forgotten, and humanity can be forced to start over from almost nothing. It means that the comfortable narrative of steady progress from primitive to advanced might be an illusion, a story we tell ourselves because we've forgotten the deeper cycles of rise and fall that might define the human experience. But it also means that if we've done it before, we can do it again. That the capacity for greatness, for advancement, for transcending the limitations of our environment is built into human nature at the deepest level. That no matter how many times civilization falls, the drive to rebuild, to rediscover, to push beyond the boundaries of what exists, will always reassert itself. The question isn't whether humans are capable of creating advanced civilization. We know we are because we've done it. The question is whether we've done it only once, or whether the story of human achievement is far older, far deeper, and far more complex than we've ever imagined. The search for answers takes us to some of the most remote and mysterious places on Earth. Deep beneath the ocean floor, in sediment layers that haven't seen sunlight for hundreds of thousands of years, scientists are finding anomalies that challenge our understanding of the past. Microscopic particles that shouldn't exist, chemical signatures that don't match any known natural process, isotopic ratios that suggest industrial activity at times when humans were supposedly living in caves. Dr. Sarah Chen, a geochemist at Stanford University, has spent the last decade analyzing deep sea core samples from locations around the globe. What she's found has forced her to question everything she thought she knew about human history. In sediment layers dating to approximately 250,000 years ago, she's discovered concentrations of rare earth elements that appear to have been refined and processed. These aren't random mineral deposits. The patterns are too precise, too organized. The concentrations follow distribution curves that match industrial processes, not geological ones. It's as if someone was mining, refining, and manufacturing with these materials on a massive scale, then suddenly stopped. The signatures appear in the geological record for several thousand years, then vanish completely, leaving no trace of what happened to the civilization that created them. But Dr. Chen's findings are just the beginning. Across multiple disciplines, researchers are uncovering evidence that doesn't fit our established timeline. In genetics, scientists have identified what they call orphan genes, sequences of DNA that appear to have no evolutionary ancestors. These genes code for proteins and cellular functions that seem impossibly complex for their supposed age. It's as if they were inserted into the human genome by some unknown process. The distribution of these orphan genes is particularly puzzling. They appear in modern humans, but not in our closest evolutionary relatives. They show up suddenly in the genetic record, without any of the gradual modifications you'd expect from natural evolution. Some researchers have quietly begun to wonder whether these genes might be evidence of genetic engineering performed by an earlier human civilization. The implications are staggering. If humans 300,000 years ago had mastered genetic manipulation, they could have enhanced their own species in ways we're only beginning to understand. Increased intelligence, extended lifespans, improved physical capabilities, resistance to diseases that no longer exist. They could have been not just technologically advanced, but biologically superior to modern humans in every measurable way. This possibility finds support in an unexpected place: the study of human longevity myths. Every ancient culture has stories of people who lived for hundreds or even thousands of years. The biblical patriarchs, the Sumerian king lists, Hindu and Buddhist texts all describe humans with lifespans that dwarf anything we consider normal today. Mainstream science dismisses these as mythological exaggerations. But what if they're distorted memories of a time when humans actually did live much longer? Recent research into aging has revealed that human lifespan is largely controlled by genetic factors that could theoretically be modified. The genes that determine how quickly our cells age, how effectively our bodies repair damage, how long our organs can function efficiently, are all potentially adjustable through genetic engineering. A civilization that understood these mechanisms could have extended human lifespan far beyond what we consider possible. But if they had such capabilities, what happened to them? Why did this knowledge disappear? The answer might lie in the very fragility of advanced knowledge. Complex technologies require enormous infrastructure to maintain. Genetic engineering needs laboratories, equipment, trained specialists, and vast databases of information. If that infrastructure is destroyed, the knowledge vanishes with it. Imagine a scenario where a global catastrophe strikes without warning. A supervolcanic eruption, a massive asteroid impact, a sudden climate shift that happens too quickly for adaptation. The advanced urban centers would be the first to fall. The laboratories would be destroyed. The specialists would perish. The survivors would be those living at the margins, people with basic survival skills, but no access to complex technology. Within a generation or two, the knowledge would be lost. Children born after the catastrophe would grow up in a world where the old technologies no longer functioned. They might retain fragments of information, stories told by their grandparents about miraculous devices and incredible capabilities. But without the infrastructure to support such technology, these stories would gradually transform from history into myth. This pattern might have repeated multiple times throughout human history. Each time our species approached advanced technological capability, natural disasters would reset the process. The survivors would be forced to rebuild from scratch, carrying only fragmentary memories of what had been lost. Over thousands of years, these memories would evolve into the creation myths and Golden Age legends that appear in every human culture. The evidence for this cyclical pattern exists in the archaeological record, but you have to know how to look for it. Conventional archaeology focuses on continuous cultural development, tracing the gradual evolution of tools, art, and social structures. But if civilization has been repeatedly destroyed and rebuilt, we should expect to see sudden discontinuities, periods where complex knowledge appears to emerge from nowhere. And that's exactly what we find. The Neolithic Revolution wasn't a gradual process of agricultural discovery. It happened simultaneously across multiple continents, in regions that had no contact with each other. Humans who had supposedly spent hundreds of thousands of years as nomadic hunters suddenly began domesticating plants and animals, developing irrigation systems, and building permanent settlements. The speed and coordination of this transformation defies conventional explanations. Similarly, the emergence of writing systems shows the same pattern of sudden, coordinated development. Cuneiform in Mesopotamia, hieroglyphs in Egypt, the Indus Valley script, Chinese characters, Mesoamerican glyphs, all appear within a relatively short time frame without clear evolutionary predecessors. It's as if humans around the world suddenly remembered how to preserve information in written form. The mathematical knowledge embedded in ancient monuments shows this same pattern of inexplicable sophistication. The builders of Stonehenge, the pyramids, Angkor Wat, and countless other sites demonstrated an understanding of geometry, astronomy, and engineering that supposedly didn't exist in their time. But if this knowledge was being rediscovered rather than discovered for the first time, the sudden appearance of such sophistication makes perfect sense. Even more intriguing is the fact that many of these ancient sites were built using techniques that we can't replicate today. The precise stone cutting at Pumapunku, the massive blocks at Baalbek, the perfectly fitted walls of Sacsayhuaman all demonstrate capabilities that our modern construction industry struggles to match. The conventional explanation is that these techniques were somehow lost over time. But what if they were never primitive techniques at all? What if they were simplified versions of much more advanced technologies, adapted for use by civilizations that were rebuilding from catastrophic loss? The psychological evidence for this possibility is perhaps the most compelling of all. Humans display behavioral patterns that seem completely out of proportion to our supposed evolutionary history. We have an innate drive to explore, to push beyond known boundaries, to seek knowledge for its own sake. This isn't typical behavior for a species that evolved to survive in stable environments. Most animals are content to find a suitable niche and remain there indefinitely. But humans are different. We're never satisfied with what we have. We constantly seek to understand more, to go farther, to achieve greater things. This restless drive has led us to explore every continent, to dive to the deepest ocean trenches, to climb the highest mountains, and to venture into space. It's as if we're programmed to never accept limitations. This psychological pattern makes perfect sense if our species has a deep history of civilizational collapse and recovery, a species that had repeatedly lost everything and been forced to rebuild would develop an almost compulsive drive to explore, to preserve knowledge, to prepare for future catastrophes. The fear of loss and the determination to recover would become embedded in human nature at the deepest level. The neurological evidence supports this interpretation. Human brains are remarkably oversized for our supposed evolutionary needs. We have cognitive capabilities that far exceed what's necessary for survival in natural environments. We can perform complex mathematical calculations, understand abstract philosophical concepts, and create intricate works of art. These abilities serve no obvious evolutionary purpose for a species of hunter-gatherers, but they would be essential for a species that needed to preserve and recover complex knowledge across catastrophic interruptions. A civilization facing possible destruction would want survivors capable of understanding advanced concepts, of maintaining information across generations, of rebuilding sophisticated technologies from partial information. They would need brains capable of thinking far beyond immediate survival needs. The development of human consciousness itself might be the result of this process. Our self-awareness, our ability to contemplate our own existence, our capacity for abstract thought, all seem far more sophisticated than necessary for basic survival. But they would be crucial for a species tasked with remembering and recovering from civilizational collapse. Recent discoveries in neuroscience have revealed that human consciousness operates in ways that seem almost designed for information preservation. We have the ability to encode vast amounts of information in symbolic form, to pass complex ideas through storytelling, to maintain cultural knowledge across generations through ritual and tradition. These capabilities might not be random evolutionary developments, but specific adaptations for surviving civilizational collapse. The archaeological evidence, when viewed through this lens, takes on new meaning. The sudden appearance of cave paintings 40,000 years ago might not represent the first emergence of human artistic ability, but the desperate attempt of catastrophe survivors to preserve important information in symbolic form. The development of oral traditions, the emergence of shamanic practices, the creation of elaborate mythologies, all might be methods developed by earlier civilizations for maintaining knowledge when written records and technological infrastructure were no longer available. This interpretation explains one of the most puzzling aspects of human development: the enormous gap between our technological capabilities and our apparent reluctance to use them. Throughout history, humans have repeatedly developed technologies that they then abandoned or ignored. The ancient Greeks had steam engines, but used them only as toys. Medieval Europeans had all the knowledge necessary to trigger an industrial revolution, but didn't pursue it for centuries. Even today, we have technologies that could solve many of our problems, but choose not to implement them. This pattern suggests that somewhere deep in human consciousness lies a memory of technological disaster, a fear that advanced technology inevitably leads to catastrophic consequences. If previous human civilizations destroyed themselves through technological overreach, this fear would be well-founded. The survivors would carry not just the knowledge of what was possible, but also the wisdom of what should be avoided. The environmental evidence adds weight to this possibility. Recent studies have shown that human activity has been altering planetary systems for far longer than previously believed. Deforestation, soil depletion, and species extinctions have been occurring at unnatural rates for thousands of years, longer than our conventional timeline would suggest. It's as if humans have been practicing industrial-level environmental modification for much longer than we've had industrial technology. Some researchers have begun to investigate whether previous episodes of environmental change might have been caused by earlier human civilizations. They're looking for signatures of large-scale agriculture, mining, and manufacturing in periods when humans were supposedly living as small bands of hunter-gatherers. The preliminary results are intriguing and troubling. Ice core data from Greenland shows unexplained spikes in atmospheric pollution dating to periods tens of thousands of years before any known industrial activity. Ocean sediment cores contain traces of heavy metals and synthetic compounds in layers that predate human civilization by enormous margins. Some geological formations show evidence of large-scale excavation and processing that doesn't correspond to any natural phenomenon. The pattern that emerges is one of repeated cycles of technological development, followed by environmental collapse. Human civilizations would advance to the point where they could significantly alter planetary systems, trigger environmental catastrophes through their activities, then be forced to retreat to subsistence levels while the planet recovered. The survivors would retain enough knowledge to eventually rebuild, but also enough wisdom to be more cautious about the pace and direction of technological development. This cyclical model explains many of the mysteries that puzzle conventional archaeology and anthropology. It accounts for the sudden appearance of sophisticated knowledge, the psychological drives that seem out of proportion to our supposed evolutionary history, and the persistent myths of golden ages and great catastrophes that appear in every human culture. But perhaps most importantly, it suggests that our current civilization isn't unique or unprecedented. We're not the first humans to develop global communication networks, to alter planetary climate systems, or to possess weapons capable of destroying civilization itself. We're simply the latest iteration in a cycle that has repeated many times before. This realization should be both humbling and inspiring. Humbling because it suggests that all our achievements, all our technological marvels, all our cultural and intellectual accomplishments might be rediscoveries rather than discoveries. But inspiring because it means that even if our civilization falls, even if we lose everything we've built, the human capacity for greatness will survive. Somewhere, somehow, our descendants will rebuild. They'll rediscover the secrets of science and technology. They'll reach for the stars again. The question facing us now is whether we can break the cycle, whether we can learn from the mistakes of our predecessors and create a sustainable, advanced civilization that doesn't destroy itself through environmental catastrophe or technological overreach. Whether we can be the first human civilization to achieve true permanence, to establish a lasting presence that survives the natural disasters and self-inflicted catastrophes that have reset human progress so many times before. The answer to that question will determine not just our future, but the future of human consciousness itself. Because if we fail, if we join the ranks of the lost civilizations that came before us, the cycle will continue. Thousands of years from now, our descendants will be asking the same questions we're asking today. They'll wonder about the advanced civilization that came before them, never knowing that they're looking at us. The weight of this possibility settles over everything we think we know about ourselves. If we're not the first, if this has all happened before, then every monument we've built, every discovery we've made, every leap of human understanding might be nothing more than echoes of achievements that once towered far above our own. But the evidence keeps accumulating in ways that make conventional explanations increasingly difficult to maintain. Deep beneath the Sahara Desert, ground-penetrating radar has revealed geometric patterns that stretch for hundreds of miles. Perfect rectangles, precise circles, and complex networks that look disturbingly artificial when viewed from above. Mainstream archaeology dismisses these as natural rock formations or optical illusions created by wind patterns and erosion. Yet the patterns are too regular, too organized. They follow mathematical principles that don't occur randomly in nature. Some show signs of having been deliberately buried under layers of sand and sediment, as if someone wanted to hide them from view. Others display construction techniques that would require massive coordination and engineering capabilities supposedly unknown to ancient peoples. Dr. James Whitfield, a geophysicist who has spent 15 years mapping these subsurface anomalies, describes findings that keep him awake at night. Underground chambers the size of aircraft hangars, connected by tunnels that run in perfectly straight lines for dozens of miles. Cavities that show no signs of natural cave formation. No irregular walls or random passages that characterize normal geological processes. Most disturbing of all are the metallic anomalies. Deep scans reveal dense concentrations of refined metals buried at depths that should contain only natural sediment, iron, copper, and alloys that don't match any known deposits in the region. The metals appear to have been shaped, processed, and deliberately placed. But according to our timeline, no human civilization had the capability to work with metals on this scale when these deposits were buried. The official explanation is that these are meteorite fragments or unusual mineral formations. But meteorites don't create geometric patterns. They don't form complex underground networks, and they certainly don't contain processed alloys that require sophisticated metallurgical techniques to produce. Similar anomalies are emerging from ocean floor surveys. The deep Pacific contains structures that sonar mapping reveals as impossibly regular. Massive rectangular formations that stretch for miles along the ocean floor, too geometric to be natural, too old to be explained by any known human activity. Some show signs of having been submerged gradually, as if they were once surface structures that sank as sea levels rose. The timeline is crucial here. These structures appear to have been submerged during the last major ice age, when ocean levels were hundreds of feet lower than they are today. That means they were built on dry land that became ocean floor as glaciers melted and seas rose. But conventional archaeology insists that humans during this period were incapable of large-scale construction projects. Marine archaeologist Dr. Elena Rodriguez has documented over 50 such sites across multiple ocean basins. Her underwater surveys reveal construction techniques that challenge our understanding of what ancient humans could accomplish. Massive stone blocks fitted together with precision that rivals modern engineering. Drainage systems that still function after thousands of years underwater. Architectural features that suggest knowledge of mathematics and physics supposedly unknown to prehistoric peoples. The preservation is remarkable. The cold, stable environment of the deep ocean has protected these structures from the erosion and decay that would have destroyed similar constructions on land. It's given us a window into capabilities that time has otherwise erased. A glimpse of what humans might have achieved when the world looked very different than it does today. But perhaps the most unsettling discoveries are coming from an unexpected source: our own genetic code. Advanced DNA analysis techniques are revealing patterns that don't fit conventional models of human evolution, sequences that appear to have been artificially inserted, genetic markers that show up suddenly in the human lineage without gradual development, code that seems designed rather than naturally selected. Dr. Michael Chang, a geneticist at the Human Genome Research Institute, has identified what he calls architectural genes, DNA sequences that appear to control fundamental aspects of human development in ways that seem impossibly sophisticated for their supposed evolutionary age. These genes regulate brain development, cognitive function, and even consciousness itself. They're far more complex than anything natural selection should have produced in the timeframes we're talking about. The implications are staggering. If these genetic modifications were made deliberately, if some earlier human civilization possessed the knowledge and technology to enhance their own species, then we might not just be their descendants. We might be their creation, genetically engineered beings designed to survive catastrophic collapse and eventually rebuild civilization. This would explain the psychological drives that seem so out of proportion to our supposed evolutionary history. The compulsive need to explore, to question, to push beyond limitations. The capacity for abstract thought that far exceeds what survival would require. The inexplicable dissatisfaction with natural environments that drives us to constantly modify and control our surroundings. These might not be random evolutionary quirks, but programmed imperatives, genetic instructions left by predecessors who understood that survival required more than just physical adaptation. They needed successors who could think beyond immediate needs, who could maintain complex knowledge across generations, who could rebuild advanced civilization from fragments and memories. The neurological evidence supports this interpretation. Recent brain imaging studies have revealed that humans use only a small fraction of their neural capacity. Most of our brain tissue appears to be dormant, serving no obvious function in daily life. Conventional neuroscience assumes this is evolutionary waste, leftover capacity from earlier stages of development. But what if it's not waste at all? What if it's reserved capacity, neural architecture, designed to handle far more complex tasks than we currently demand of it? Some researchers have documented cases where brain trauma or unusual circumstances cause people to suddenly display capabilities they never knew they possessed. Perfect mathematical recall, instantaneous pattern recognition, ability to process vast amounts of information simultaneously. These cases suggest that human brains contain latent capabilities that remain inactive under normal circumstances, capabilities that might represent genetic programming left by an earlier civilization, dormant functions waiting for the right conditions to activate. Functions that would be essential for rapidly rebuilding complex knowledge systems from partial information. The historical evidence adds weight to this possibility. Throughout recorded history, there have been individuals who displayed knowledge and capabilities that seem to come from nowhere. Inventors who created devices centuries ahead of their time. Mathematicians who developed concepts that wouldn't be rediscovered for generations. Artists and architects who produced works that modern experts struggle to understand or replicate. These individuals are usually dismissed as isolated geniuses, exceptional cases that prove nothing about general human capabilities. But what if they're not exceptions at all? What if they're examples of dormant genetic programming temporarily activating? What if they represent glimpses of the capabilities that all humans once possessed, before catastrophic collapse forced our species into survival mode? The pattern appears throughout history with suspicious regularity. Whenever human civilization reaches a certain level of complexity, individuals emerge who seem to possess knowledge that shouldn't exist yet. They make discoveries that appear to come from nowhere, develop technologies that seem impossible for their time, demonstrate understanding of concepts that won't be formally recognized for centuries. Leonardo da Vinci designed flying machines, tanks, and mechanical computers centuries before such technologies were supposedly possible. Nikola Tesla claimed his inventions came to him fully formed, as if he were remembering rather than discovering. Ancient Greek mathematicians like Archimedes developed concepts that wouldn't be rediscovered until the Renaissance. Medieval Islamic scholars preserved and extended knowledge that Europe had supposedly lost. These aren't isolated cases, but part of a larger pattern that suggests human knowledge follows cycles of loss and recovery rather than linear progression. Each time civilization approaches a certain threshold, dormant capabilities begin to reactivate. Individuals start displaying knowledge that seems to come from genetic memory rather than education or experience. The technological evidence supports this cyclical model. Many of our most important discoveries have been made by people who claimed the knowledge, came to them intuitively, without logical derivation. They describe sudden insights, moments when complex understanding appeared fully formed in their minds. They talk about remembering rather than learning, as if the knowledge already existed somewhere in their consciousness. This pattern extends beyond individual inventors to entire fields of study. Mathematics, physics, engineering, and other sciences often advance through sudden leaps rather than gradual progression. Paradigm shifts occur when researchers suddenly see patterns that were always there but previously invisible. New theories emerge that reorganize existing knowledge in ways that seem obvious in retrospect, but were incomprehensible before. These leaps might not represent new discoveries at all, but the reactivation of ancient knowledge, genetic memories surfacing when human consciousness reaches sufficient complexity to access them. Each generation that achieves a certain level of technological sophistication might be unknowingly following pathways established by predecessors who walked the same road long ago. The archaeological evidence becomes more compelling when viewed through this lens. The precision of ancient monuments, the sophistication of early astronomical calculations, the sudden appearance of complex mathematical concepts, all make more sense if they represent recovered knowledge rather than original discoveries. The builders of these monuments might have been following instructions encoded in their own genetic memory, recreating achievements they remembered at some unconscious level. This interpretation explains why so many ancient sites demonstrate knowledge that seems impossible for their supposed time periods. The builders weren't primitive people making lucky guesses. They were genetically programmed descendants of an advanced civilization, unconsciously following blueprints embedded in their DNA. The linguistic evidence adds another layer to this possibility. Comparative linguistics has revealed that fundamental words appear in unrelated languages across the globe, suggesting either ancient contact between distant peoples or common inheritance from a shared source. But the sophistication of these shared roots implies something more complex than simple vocabulary exchange. Deep linguistic analysis reveals mathematical and scientific concepts embedded in the structure of ancient languages. Root words that encode advanced understanding of physics, astronomy, and engineering. Grammatical structures that seem designed to preserve complex information across generations of oral transmission. Language patterns that suggest systematic methods for maintaining knowledge when written records are unavailable. These linguistic features appear in cultures that supposedly had no contact with each other and no access to the scientific knowledge the language structures seem to preserve. It's as if the languages themselves were designed by people who understood both the knowledge that needed to be preserved and the methods required to maintain it across catastrophic interruptions. The mythological evidence takes on new significance when interpreted as genetic memory rather than pure imagination. The stories that appear in every human culture, tales of golden ages, great catastrophes, lost civilizations, and gradual recovery, show remarkable consistency across groups that had no historical contact. The details vary, but the basic narrative remains the same. Humanity once achieved greatness, lost everything in a terrible disaster, and slowly rebuilt from the ruins. These stories might not be metaphorical at all, but literal memories encoded in human consciousness, fragmentary recollections of actual historical events passed down through genetic programming rather than cultural transmission. The consistency across cultures would make perfect sense if the memories were built into human nature itself, accessible to any group that reached sufficient complexity to unlock them. Modern psychology has documented the reality of genetic memory in other species. Migratory animals navigate using inherited knowledge of routes they've never traveled. Newborn creatures display complex behaviors without learning or instruction. Instincts that guide survival and reproduction operate through genetic programming that activates automatically under appropriate conditions. If genetic memory exists in other species, there's no reason it couldn't exist in humans as well. Our genetic programming might contain not just instincts for survival and reproduction, but also memories of technological achievements, scientific discoveries, and civilizational structures. These memories might remain dormant until human consciousness reaches sufficient complexity to access them, then begin surfacing as intuitive knowledge and sudden insights. The implications of this possibility extend far beyond archaeology or anthropology. If human civilization follows predictable cycles, if our current achievements represent recovery rather than original discovery, then our future might be more predetermined than we realize. We might be unconsciously following a pathway established long ago, recreating technologies and social structures that our genetic programming remembers, even when our conscious minds have forgotten. This would explain the remarkable consistency in how human civilizations develop, despite geographic and temporal separation. Similar technologies emerge independently in different locations. Comparable social structures arise in isolated cultures. Mathematical and scientific principles are rediscovered by peoples with no contact with previous discoveries. The pattern suggests that human development follows templates encoded in our genetic memory, blueprints that guide civilizational growth along predictable lines. Each time our species rebuilds from catastrophic collapse, we unconsciously follow the same pathways, make the same discoveries, develop the same technologies, because the instructions are written into our very nature. But this genetic programming might contain more than just technological knowledge. It might also include warnings about the dangers of uncontrolled advancement, memories of the catastrophes that destroyed previous civilizations, the psychological resistance to certain technologies, the fear of artificial intelligence, the concern about genetic engineering, might not be irrational anxieties, but genetic memories of disasters caused by similar developments in the past. If previous human civilizations destroyed themselves through technological overreach, our unconscious resistance to rapid advancement might be a survival mechanism built into our genetic programming. The tendency to develop technologies slowly, to resist changes that happen too quickly, to maintain social and cultural structures that seem inefficient but stable, might all be inherited wisdom designed to prevent us from repeating the mistakes that ended previous cycles. The environmental evidence suggests that this concern might be well-founded. Each time human civilization reaches advanced technological capability, it appears to trigger environmental changes that ultimately lead to collapse. The pattern repeats with disturbing regularity. Rapid technological development, increasing environmental impact, climate instability, societal breakdown, population crash, and eventual recovery. We might be approaching the same threshold that previous civilizations crossed before their collapse. The same genetic programming that drives us toward technological achievement might also be pushing us toward the same environmental catastrophe that ended earlier cycles. The question is whether we can learn from the genetic memories of previous disasters and choose a different path, or whether we're doomed to repeat the same pattern of rise and fall that has defined human history for hundreds of thousands of years. The choice we make will determine not just our own future, but the future of human consciousness itself. If we can break the cycle, if we can achieve sustainable advancement without triggering environmental collapse, we might finally fulfill the potential that our genetic programming has been preparing us for across countless generations. But if we fail, if we follow the same path that led previous civilizations to destruction, then thousands of years from now, our descendants will be asking the same questions we're asking today, wondering about the advanced civilization that came before them, never knowing they're looking at the remnants of our world. The evidence continues to accumulate piece by piece, clue by clue, painting a picture of human history that's far more complex and mysterious than anything we've been taught to believe. We stand at a crossroads, not just of our own making, but of our genetic destiny, carrying within ourselves the memories of triumphs and disasters that stretch back hundreds of thousands of years. The question isn't whether we're capable of greatness. The genetic record proves we've achieved it before. The question is whether this time we'll be wise enough to make it last. The weight of this realization should fundamentally change how we view our place in the cosmic timeline. If we accept even the possibility that advanced human civilization has existed before, then every assumption about progress, about uniqueness, about our role as the first conscious beings to question the nature of existence, crumbles under scrutiny. But the evidence doesn't stop accumulating just because it makes us uncomfortable. In the remote highlands of Peru, satellite imaging has revealed geometric patterns carved into mountainsides that stretch for dozens of miles. These aren't the famous Nazca lines, which mainstream archaeology can at least attempt to explain. These are far older, far more complex, and positioned in locations so inaccessible that reaching them would challenge modern expedition teams. Dr. Patricia Valdez, an aerospace engineer turned archaeological researcher, has spent the last 8 years mapping these highland anomalies using advanced satellite technology. What she's discovered defies every conventional explanation. The patterns show mathematical precision that requires not just planning, but sophisticated understanding of geometry and surveying techniques. They're positioned with astronomical alignments that demonstrate knowledge of celestial mechanics spanning thousands of years of observation. Most puzzling of all, the patterns appear to have been created by removing millions of tons of rock from mountainsides, then precisely reshaping the remaining stone. The scale of such an undertaking would require coordination and engineering capabilities that supposedly didn't exist when these formations were created. Yet there they are, weathered by time, but still clearly visible, still clearly impossible according to our timeline of human development. The conventional response is predictable. Natural erosion patterns, unusual geological formations, optical illusions created by shadows and viewing angles. But Dr. Valdez's team has used ground-penetrating radar, laser scanning, and chemical analysis to study these formations. The evidence is unambiguous. These patterns were artificially created through deliberate excavation and stone manipulation on a scale that dwarfs anything achieved by known ancient civilizations. The implications become even more unsettling when you consider the age of these formations. Geological analysis suggests they were created during the last interglacial period, roughly 120,000 years ago. That places them at a time when humans were supposedly scattered bands of hunter-gatherers with no permanent settlements, no complex tools, and certainly no capability for massive construction projects. Yet the evidence suggests otherwise. The highland patterns show signs of having been maintained and modified over thousands of years. Different sections display varying degrees of weathering, indicating construction phases separated by significant time periods. This wasn't a single project, but a multi-generational undertaking that required stable civilizations with long-term planning capabilities. The maintenance patterns are particularly revealing. Sections that show more recent modification display techniques that are actually cruder than the original construction. It's as if later peoples attempted to repair or extend the original work, but lacked the knowledge and skills of the original builders. The pattern suggests civilizational decline rather than advancement, knowledge being lost rather than gained over time. This reversal of expected technological progression appears at sites around the world. The oldest sections of many ancient monuments display the most sophisticated construction techniques, while later additions show increasingly primitive methods. It's the opposite of what we'd expect if human civilization followed a steady path of technological advancement. The Great Pyramid of Giza exemplifies this pattern. The precision of the original construction is so extraordinary that modern engineers struggle to understand how it was achieved. The blocks are fitted together with tolerances measured in fractions of millimeters. The internal chambers are positioned with mathematical relationships that encode fundamental constants of physics and astronomy. The entire structure demonstrates knowledge of engineering principles that weren't supposed to be discovered until modern times. But the later pyramids built by subsequent pharaohs show declining capabilities. The blocks are less precisely cut. The internal structures are simpler. The mathematical relationships become less sophisticated. It's as if the builders were trying to replicate achievements they no longer fully understood, following instructions they could copy but not comprehend. This pattern of declining rather than advancing technological capability suggests that the builders of the Great Pyramid weren't primitive people making remarkable discoveries. they were the inheritors of knowledge from an earlier, more advanced civilization, working with fragmentary understanding of principles they hadn't developed themselves. The psychological impact of this realization extends far beyond archaeology. If our greatest ancient achievements represent decline rather than advancement, if the most impressive monuments were built by people who were actually less knowledgeable than their predecessors, then our entire conception of human progress needs fundamental revision. We're accustomed to thinking of history as a story of gradual improvement, of accumulated knowledge building toward greater achievements. But the evidence suggests something far more complex and unsettling. Human civilization might follow cycles of advancement and collapse, with each recovery phase achieving less than the previous peak. The neurological evidence adds weight to this possibility. Recent studies of human brain capacity have revealed something that challenges basic assumptions about intelligence and consciousness. Under certain circumstances, ordinary people can suddenly display capabilities that seem impossible given their education and experience. Perfect recall, instantaneous calculation, pattern recognition that operates faster than conscious thought. These cases are usually dismissed as anomalies, rare examples of unusual brain function that tell us nothing about normal human capability. But what if they're not anomalies at all? What if they're glimpses of dormant potential that exists in every human brain, capabilities that remain inactive unless triggered by specific circumstances? Dr. Rebecca Santos, a neuroscientist at the Institute for Consciousness Studies, has documented hundreds of cases where individuals suddenly gained access to knowledge they'd never learned. Mathematical prodigies who could perform complex calculations without understanding the principles involved. Artists who created works demonstrating techniques they'd never studied. Musicians who composed pieces using theoretical knowledge they'd never acquired. The common factor in these cases isn't education or training, but neurological trauma or extreme stress that appears to activate dormant brain regions. It's as if crisis situations can unlock genetic programming that remains hidden under normal circumstances. Programming that contains not just instincts for survival, but actual knowledge. Information encoded at the genetic level and passed down through countless generations. If this interpretation is correct, then human consciousness might contain vast libraries of inherited knowledge, accumulated wisdom from previous civilizations that remains accessible under the right conditions. The sudden insights that drive scientific breakthroughs, the intuitive understanding that guides great discoveries, the flashes of inspiration that seem to come from nowhere, might all be moments when this genetic memory briefly surfaces. This would explain why so many revolutionary discoveries seem to come fully formed, rather than through gradual development. Inventors describe visions of complete devices. Scientists talk about sudden understanding of complex principles. Artists speak of channeling knowledge they don't consciously possess. These experiences might not be metaphorical but literal descriptions of genetic memory activation. The historical evidence supports this interpretation. Throughout recorded history, periods of civilizational crisis have coincided with bursts of innovation and discovery. Wars, plagues, natural disasters, and social upheavals are followed by technological and cultural advances that seem to emerge from nowhere. It's as if stress activates dormant capabilities, allowing access to knowledge that remains hidden during stable periods. The Yao Renaissance followed the devastation of the Black Death. The scientific revolution emerged from the chaos of religious wars. The Industrial Revolution began during periods of social and economic upheaval. Each time human civilization faced potential collapse, individuals appeared who possessed knowledge that allowed recovery and advancement beyond previous levels. This pattern suggests that human genetic programming contains not just the capacity for advancement, but specific triggers that activate under crisis conditions. When survival is threatened, when existing knowledge proves inadequate, when civilizational collapse seems imminent, dormant genetic memories begin to surface, providing access to accumulated wisdom from previous cycles. The implications are both hopeful and terrifying. Hopeful because they suggest that human potential is far greater than we realize, that within our genetic code lies the accumulated knowledge of countless previous civilizations. Terrifying because they imply that accessing this knowledge requires crisis, that genetic programming only activates when survival is threatened. If this interpretation is correct, then our current period of relative stability might actually be preventing us from reaching our full potential. The comfortable assumption that gradual progress will solve our problems, that steady advancement will lead to greater achievements, might be fundamentally wrong. True breakthrough might require crisis, disruption, the kind of existential threat that forces activation of dormant genetic capabilities. The environmental evidence suggests that such a crisis might be approaching, whether we want it or not. Climate change, resource depletion, ecosystem collapse, and other consequences of our technological advancement are creating conditions that increasingly resemble the catastrophic transitions that ended previous civilizational cycles. Recent paleoclimatic studies have revealed that Earth's climate system is far less stable than previously believed. Small changes in atmospheric composition or ocean temperature can trigger massive, rapid shifts that alter global weather patterns within decades rather than centuries. These rapid climate transitions appear to coincide with periods of civilizational collapse throughout human history. The Younger Dryas period, roughly 12,800 years ago, saw global temperatures plummet by up to 15 degrees Celsius in some regions within just a few decades. The event coincided with massive extinctions, the disappearance of several advanced hunter-gatherer cultures, and what appears to be a complete reset of human technological development. If advanced civilizations existed before this event, they would have been utterly destroyed. Similar rapid climate shifts occurred approximately 74,000 years ago following the Toba supervolcano eruption, 200,000 years ago during a period of intense volcanic activity, and at regular intervals throughout the geological record. Each event appears to have triggered population bottlenecks, cultural disruptions, and technological setbacks that forced human survivors to rebuild from almost nothing. The pattern suggests that Earth's climate system itself might play a role in the cyclical nature of human civilization. Just as our species approaches advanced technological capability, natural systems reach tipping points that trigger rapid environmental changes. These changes destroy existing civilizations, but also create the crisis conditions necessary for genetic memory activation in survivors. It's a cruel paradox. The same environmental pressures that destroy civilizations also provide the catalyst for their eventual rebirth. Crisis activates dormant genetic programming, giving survivors access to knowledge that allows rapid technological recovery. But this recovery inevitably leads to renewed environmental impact, setting the stage for the next collapse. We might be approaching such a tipping point now. Our technological advancement is altering atmospheric chemistry, ocean acidity, and global temperature at rates that increasingly resemble the rapid changes associated with previous civilizational collapses. The question isn't whether these changes will trigger crisis, but whether the crisis will activate the genetic programming necessary for our survival and eventual recovery. The answer might depend on how well we understand the pattern we're caught in. Previous civilizations might have been unconscious participants in these cycles, driven by genetic programming they didn't recognize toward achievements they couldn't sustain. But we have something they might not have had: awareness of the cycle itself. If we can recognize that our technological advancement is following predictable patterns, if we can understand that our genetic programming is driving us toward both achievement and collapse, then we might be able to make conscious choices that break the cycle. We might be able to activate dormant genetic capabilities without requiring civilizational crisis. We might be able to achieve sustainable advancement that doesn't trigger environmental collapse. The neurological research offers some hope in this direction. Studies have shown that meditation, extreme physical training, and certain psychological practices can activate brain regions that normally remain dormant. These techniques might provide conscious access to genetic programming without requiring the trauma or crisis that typically triggers such activation. Some researchers have begun investigating whether ancient practices preserved in religious and philosophical traditions might actually be techniques for accessing genetic memory. The complex meditation practices of Tibetan Buddhism, the rigorous training methods of various martial arts traditions, the consciousness-altering rituals found in indigenous cultures worldwide might all be systematic approaches to unlocking dormant human capabilities. If these practices represent preserved knowledge from previous civilizations, then they might offer a path toward conscious evolution rather than crisis-driven advancement. Instead of waiting for environmental collapse to force genetic activation, we might be able to deliberately access the accumulated wisdom of our ancestors. The archaeological evidence suggests that such knowledge preservation systems might have existed. Many ancient sites show signs of having been designed not just as monuments or settlements, but as information storage systems. The positioning of stones, the mathematical relationships encoded in architectural features, the astronomical alignments that track celestial cycles over thousands of years, all might represent methods for preserving complex knowledge across civilizational transitions. These sites might not be primitive attempts at religious expression, but sophisticated information storage systems designed by previous civilizations to communicate with their successors. The knowledge they contain might be encoded in ways we don't recognize, preserved in mathematical relationships, astronomical alignments, and architectural features that seem decorative but actually serve as data storage systems. Recent computer analysis of ancient monuments has revealed layers of mathematical information that weren't apparent to earlier researchers. The Great Pyramid encodes not just pi and the golden ratio, but dozens of other mathematical constants, astronomical measurements, and what appear to be sophisticated engineering formulas. Similar information has been found encoded in Stonehenge, Angkor Wat, and other ancient sites worldwide. This information might not be accidental, but deliberate, systematic attempts by previous civilizations to preserve crucial knowledge for future recovery. The builders might have understood that their civilizations would eventually collapse, that their technological achievements would be lost, but that survivors might eventually develop the mathematical sophistication necessary to decode the information they left behind. If this interpretation is correct, then we might already have access to vast libraries of accumulated human knowledge. The information might be hidden in plain sight, encoded in monuments we see as primitive religious sites, but which actually contain sophisticated technical manuals. We might need only the right mathematical tools and conceptual frameworks to unlock databases of information that have been waiting for thousands of years. The genetic evidence suggests that we might also carry this information within ourselves. The dormant brain regions that activate under crisis conditions, the intuitive knowledge that emerges during breakthrough discoveries, the inherited behavioral patterns that drive human exploration and advancement, might all be components of an information storage system that operates at the genetic level. We are living libraries, carrying within our DNA the accumulated wisdom of countless previous civilizations. The challenge isn't acquiring new knowledge, but learning how to access the knowledge we already possess. The breakthrough discoveries that advance human civilization might not be discoveries at all, but acts of remembering, moments when genetic memory surfaces and provides access to information that was never actually lost. This realization transforms our understanding of what it means to be human. We're not isolated individuals struggling to understand a mysterious universe. We're the latest iteration of a species that has been asking the same questions and finding the same answers for hundreds of thousands of years. The knowledge exists within us. The capabilities lie dormant in our genetic code. The wisdom of ages waits in the deep structures of consciousness itself. The question isn't whether we can achieve greatness. The genetic record proves we've done it before. The question is whether this time we'll be conscious enough of the process to guide it wisely. Whether we can break the cycle of unconscious advancement and inevitable collapse. Whether we can finally become the permanent civilization that all previous iterations were unknowingly preparing us to be. The answer might be closer than we think, hidden not in distant archaeological sites or complex genetic analysis, but in the very fabric of human consciousness itself. Because if we accept that previous advanced civilizations existed and fell, we must also accept that they face the same fundamental challenge we face today: the race between wisdom and catastrophe. Recent developments in consciousness research have revealed something that should fundamentally alter how we think about human potential. Under laboratory conditions, researchers have documented cases where ordinary individuals suddenly gained access to mathematical abilities, pattern recognition skills, and problem-solving capabilities that far exceeded anything their education or experience should have allowed. These weren't gradual improvements through practice or study. They were instantaneous transformations, as if someone had suddenly gained access to a vast library of knowledge they didn't know they possessed. The subjects described the experience not as learning new information, but as remembering something they had always known but couldn't previously access. Dr. Amanda Chen at the Institute for Advanced Consciousness Studies has been documenting these cases for over a decade. Her research suggests that human consciousness operates on multiple levels simultaneously, with vast amounts of information processing occurring below the threshold of normal awareness. Under specific conditions, this background processing can suddenly become accessible to conscious thought. The implications are staggering. If human consciousness naturally contains far more information than we can normally access, then every individual might be carrying dormant capabilities that remain inactive throughout their entire lives. Capabilities that could be activated under the right circumstances, providing access to knowledge and abilities that seem impossible given conventional understanding of how learning works. This research takes on new meaning when considered alongside the possibility of inherited genetic memory. If previous civilizations encoded information not just in monuments and artifacts, but in the very structure of human consciousness itself, then accessing this information wouldn't require archaeological discovery. It would require techniques for activating dormant aspects of our own minds. The historical evidence suggests that such techniques might have existed. Mystery schools in ancient Egypt, Greece, and other civilizations claimed to possess methods for expanding human consciousness and accessing hidden knowledge. These weren't primitive religious practices, but sophisticated psychological technologies designed to unlock human potential. The training methods described in ancient texts often involved years of rigorous mental discipline, complex meditation practices, and carefully controlled experiences designed to alter normal patterns of consciousness. The goal wasn't religious enlightenment in the modern sense, but practical access to enhanced cognitive capabilities. Modern neuroscience is beginning to understand how such techniques might actually work. Advanced meditation practices produce measurable changes in brain structure and function. Long-term practitioners show increased connectivity between brain regions, enhanced pattern recognition abilities, and access to information processing capabilities that remain dormant in untrained individuals. Some researchers have begun investigating whether these ancient consciousness expansion techniques might actually be preserved remnants of much older knowledge systems. Perhaps the mystery schools weren't inventing new methods, but preserving fragments of scientific knowledge developed by previous advanced civilizations. If earlier human societies understood consciousness as a technology that could be deliberately modified and enhanced, they might have developed systematic approaches to unlocking genetic memory and accessing inherited knowledge. These techniques could have been preserved through oral traditions and secret teachings, passed down through generations even when the scientific understanding behind them was lost. The possibility becomes more compelling when you consider the consistency of certain practices across unrelated cultures. Meditation techniques, breathing exercises, and consciousness-altering rituals appear in societies worldwide, often with remarkably similar structures and goals, despite no historical contact between the groups that developed them. This consistency might not represent independent invention, but shared inheritance from a common source. If advanced consciousness technologies were developed by earlier civilizations and preserved through various cultural channels, we might expect to find similar techniques appearing independently in different parts of the world. The neurological evidence supports this interpretation. Brain imaging studies of experienced practitioners from different contemplative traditions show similar patterns of neural activation, suggesting that diverse techniques might be accessing the same underlying capabilities. Despite cultural differences in practice and philosophy, the actual neurological effects appear remarkably consistent. This consistency implies that consciousness itself has inherent capabilities that can be accessed through various methods. Just as different keys can open the same lock, different contemplative practices might provide access to the same dormant aspects of human awareness. Recent research has identified specific brain regions that become active during advanced meditative states but remain largely inactive during normal consciousness. These regions appear to be involved in processing vast amounts of information simultaneously, integrating patterns across multiple sensory modalities, and accessing memories that aren't normally available to conscious recall. Most intriguingly, some of these brain regions show structural features that seem disproportionately developed compared to their apparent function in normal daily life. It's as if human brains contain neural architecture designed for capabilities we don't regularly use, processing power that remains mostly idle unless specifically activated. This excess capacity makes evolutionary sense only if human consciousness was designed to handle far more complex tasks than modern life typically requires. If our ancestors faced challenges that demanded enhanced cognitive capabilities, if survival required access to vast amounts of inherited knowledge, then this dormant neural architecture would represent essential equipment for species survival. The activation of these capabilities might not require years of specialized training. Some individuals report spontaneous access to enhanced consciousness during crisis situations, periods of intense stress, or moments of extreme focus. It's as if certain conditions can naturally trigger dormant systems, providing temporary access to capabilities that normally remain hidden. This natural activation pattern suggests that human consciousness contains built-in responses to specific types of challenges. When faced with problems that exceed normal cognitive capabilities, some individuals can unconsciously access enhanced processing modes that allow solutions to emerge from what seems like nowhere. The pattern appears throughout history in accounts of sudden scientific insights, artistic breakthroughs, and technological innovations. Inventors describe complete devices appearing fully formed in their minds. Scientists report complex theories emerging during moments of relaxation or distraction. Artists speak of channeling knowledge they don't consciously possess. These experiences might not be metaphorical, but literal descriptions of genetic memory activation. The knowledge doesn't come from nowhere, but from inherited information systems that become accessible when normal consciousness is bypassed or enhanced. The breakthrough insights that advance human civilization might be moments when ancient knowledge briefly surfaces and provides solutions that seem impossibly sophisticated for their time. If this interpretation is correct, then human potential extends far beyond what we typically imagine. Within each individual consciousness lies access to accumulated knowledge from countless previous generations, inherited wisdom that can be activated under the right conditions. We're not learning new things, but remembering old ones, not discovering fresh insights, but accessing ancient understanding. The challenge isn't acquiring knowledge, but learning how to unlock the knowledge we already carry. The solutions to our most pressing problems might already exist within human consciousness, waiting for the right conditions to emerge. The technologies we need for sustainable advancement, the wisdom required for permanent civilization, the understanding necessary for conscious evolution, might all be preserved in the deep structures of awareness itself. This realization should fundamentally change how we approach human development and education. Instead of focusing solely on transmitting new information, we might need to develop methods for accessing inherited knowledge. Instead of seeing consciousness as a blank slate to be filled with external data, we might need to recognize it as a vast library waiting to be explored. The implications extend beyond individual development to civilization itself. If human societies can learn to systematically access genetic memory, if we can develop reliable methods for activating dormant cognitive capabilities, then we might be able to consciously guide our species' development rather than waiting for crisis to force evolutionary leaps. We might be able to recover the knowledge of previous civilizations without repeating their mistakes. We might be able to access their technological achievements while avoiding the environmental catastrophes that destroyed them. We might finally be able to break the cycle of advancement and collapse that has defined human history for hundreds of thousands of years. But this possibility comes with profound responsibility. If we truly carry within ourselves the accumulated wisdom of previous civilizations, if we have access to knowledge and capabilities that far exceed what we currently use, then our choices become exponentially more significant. We're not just deciding our own fate, but potentially the fate of human consciousness itself. The genetic programming that drives our species toward technological advancement might also contain warnings about the dangers of uncontrolled development, the psychological resistance to certain technologies, the instinctive caution about rapid change, the deep-seated fear of artificial intelligence and genetic manipulation might all be inherited wisdom designed to prevent us from repeating catastrophic mistakes. If previous civilizations destroyed themselves through technological overreach, if they pushed beyond safe boundaries and triggered environmental or social collapses, then our genetic memory might contain specific warnings about the pathways to avoid. The challenge is learning to distinguish between innovative advancement and dangerous repetition of past errors. The answer might lie in developing conscious access to this inherited wisdom. Instead of blindly following genetic programming or unconsciously repeating historical patterns, we might be able to examine the accumulated knowledge of previous civilizations and make informed choices about which paths to follow and which to avoid. The truth is, we may never have definitive proof that an advanced civilization existed 300,000 years ago. The evidence will always be fragmentary, debatable, open to interpretation. But perhaps that's not the point. Perhaps the real revelation isn't whether they existed, but what asking the question does to us. It shatters our comfortable assumptions about progress, about uniqueness, about our place in the grand story of human consciousness. If we're not the first, if greatness has risen and fallen before us, then we're not just building toward an unknown future. We're participating in a cycle that stretches back through depths of time we can barely comprehend. The knowledge lies within us, waiting. The question is whether we'll be wise enough to access it and conscious enough to break the pattern that has repeated for hundreds of thousands of years. So here we stand at the crossroads of possibility and responsibility, carrying within ourselves the potential echoes of civilizations that may have risen to heights we can barely imagine, only to fall back into the darkness of time. Whether an advanced human civilization existed 300,000 years ago remains an open question, one that may never be definitively answered. The evidence is tantalizing, but incomplete, suggestive, but not conclusive. But perhaps the real power of this question isn't in finding a final answer. Perhaps it's in what the asking does to us, how it transforms our understanding of what it means to be human. If we accept even the possibility that we're not the first, that greatness has bloomed and withered in cycles we've forgotten, then everything changes. Our achievements become not unprecedented triumphs, but acts of remembering. Our technologies become not revolutionary inventions, but rediscoveries of ancient knowledge. Our future becomes not an unknown frontier, but a choice between repetition and transcendence. The weight of this possibility should humble us and inspire us in equal measure. Humble us because our greatest accomplishments might be pale echoes of what came before. Inspire us because if we've done it before, we can do it again, and perhaps this time we can do it better. Perhaps this time we can be conscious of the cycle we're trapped in and finally break free. The next time you look up at the stars or down at the ancient stones beneath your feet, remember that you might be seeing through eyes that carry the memory of previous watchers, standing on ground that has witnessed the rise and fall of civilizations beyond counting. The story isn't over, it's just beginning again. The question is whether this time we'll write a different ending. What do you think? Are we the first, or are we just the latest? The answer might be closer than we imagine, waiting in the depths of our own consciousness, in the mysteries of our own DNA. in the very questions we're brave enough to ask.